The following content is supported by victoris.org.
Let's start conditionals 2, where we have learned how to evaluate basic true or false statements so far. But what if we want to evaluate multiple conditionals? Okay, so I asked the user for their input, store it in the variable called x. The user inputted cat. Okay, awesome. Okay, so line 2's conditional is true, executed line 3. Anything in the else, which is lines 5 to 7, 8, 4 to 8, 5 to 8, is not run. Okay, then what if I input dog instead? Then we move, right? And what if I input owl? Then it's by. Wait, so what's happening over here? There's actually quite a few jumps. We input the owl. Owl is not equal to cat. So it ignores line 3, goes to it executes line 5 to 8. Okay, then is owl equals to dog? Not true. So we ignore line 6, execute line 8, which is why I see by. But we can see that if we want to add more and more, right? If we want to add a few more animals, it's going to get very, very, very long. And so is there a better way? You see, effectively what I'm doing here is else if, right? Python actually allows us to shorten that into else if. So now we see if x is cat, print meow, else if x is dog, print wolf, and then now it's much neater. Okay, so else if is so Python will go through each of these conditionals one by one until it hits one of them that is true. It will execute that one and then ignore the rest. Does that make sense?
Why do you need that when you can just if then you else everything?
No.
If you if everything.
If you if everything, right? So like the previous line, it's because if you do it the previous way, the code will drift to the right quite fast. So what I'm trying to say is, if I did it the previous way, the code, because every time I have a if, right, the indentation must increase by 1.
Oh.
Right. So if I have many, then it looks like a diagonal. The code will be eventually further and further to the right. This is just a neater way to do it. Both are logically the same, but this is a neater way. Alright?
So the only difference is just this is neater.
Yeah.
Okay, okay.
Okay. And so there's something to something to note, right? Is that if one of the conditionals is true, it will execute that corresponding block and the rest of them are ignored. The rest of them are effectively in else ifs. So what I'm trying to say is that, let's say I have x equals to 10, right? If x is greater than, let's say if x greater than 15, okay, print a. Okay, L if x is greater than, let's say 10, let's say 9, print b. L if x greater than 4, print c. Else print d. Can you guess what the output is going to be? It's okay if you get it wrong.
In 9. The B.
B.
Yeah.
B alone?
Yeah.
You're correct. So it goes to check the first one, false, so it ignores. Goes to check the next one, true, it runs this. Because this one was true already, the rest of then, the 6 and 8 ignored. Okay? It would be different if I remove the L here. Then you see that there are actually 2 separate blocks. In this case, if I run, you'll see B and C. So it ran this one, and then this one is a new conditional block, right? If x is greater than, so there's a difference between having an else if here versus a if. Yeah. Okay, so what if I want to check if 2 conditionals are both true?
Huh?
So I have a gender variable equals to the value, the string male, age equals to 19. If gender equals to male, and then you execute these 2 lines, right? Then these 2 lines will check if age is 19. If this line is true, then it says hi. So basically, line...
That's cool.
Cool, right? You can nest them. These are called nested conditionals. So line 5 is only going to be run if both conditionals are true. Yeah. But as you can see, if I want to check 10 conditionals, then it's going to be slanting all the way to the right, because each one I need to have a bit more space, a bit more indentation. So how do I combine it? I can use the and keyword. So this entire conditional is only true. You see that this entire conditional is made out of two parts, or actually three parts. The first conditional, gender equals male. The and keyword, right? And the last one is the age equals 19 conditional. Two conditionals. This entire conditional has the value of true only if both of them is true. Okay? So what does this and keyword do? If I have true and true is true. True and false is false. False and true is false. False and false is false. You can see that something and something is only true if both of them are true. It's just English, right? A and B. Okay, so what's the following output going to be? Okay, so let's break this down, right? There's two conditionals in here. X is less than 8. Is that true?
Yeah.
Yeah, so this is true. X
So
is less than 1
true.
is false, right?
Is it? Yes.
This one
false.
alone is true. This one alone is false. True and false, are they both true? It's false, right? So the answer would be false, correct. Understand? Okay, yeah, false. Okay, here's the explanation. We evaluate them individually, is true and false. Together, because one of them failed to be true. So not all of them is true. Yeah. So we have the and keyword. So what if we have the following code? So remember, it checks the first conditional, then it checks the second conditional, and it checks the third conditional. Okay, great. So what's happened over here, right? Line 2 conditional is false, right? So it doesn't run line 3 and 4. It goes to check the next one. Line 5's conditional is false also, it doesn't run line 6 and 7. It checks line 8. Line 8 conditional is true because the user input 5 and the right hand side, left hand side equal, right? So it runs line 9 and 10. But we see something interesting, right? Like no matter which one of these were true, the same lines of code executed. Meow wolf, meow wolf, meow wolf, right? So what if I want to, so is there a neater way to do this? I can combine it to an or statement. So an or statement would take in, so since the codes are repeated, right, we want to reduce our repeating of ourselves. That's the whole point of coding. We want to reduce our repetition. So we can use the or keyword, and if any one of these are true, then the entire conditional is true. Okay, so this is the different implementation of the same logic. And so maybe previously I showed you, right, but maybe now you want to guess what it's going to be. So the or keyword would, when you have something and something, it was only true if both of them are true, right? What about the or? Can you give a guess of what does or do? If something or something. Okay, you guess is okay, right? So what is the, okay, so true or false, true or true is true. Okay, false or true, as long as, so the correct answer is that as long as for the or keyword, as long as any one of them is true, then the entire statement is true. Like one of them carries the team. So in the end statement, it's more like everyone better be on board, everyone better be on the same page. All statements, like as long as one guy is true, right, he can carry the entire statement. Okay, yeah. So lastly, we have our last logical operand. Okay, this is just a recap. Yeah. Okay, great. Yeah. Okay, so you understand?
Can.
I think we have one more. Okay, so using conditionals, we can create a password activated door, right? Only if the password is correct, right? Then we let the person through. That's basically how logins work. Okay, great. So what was the code over here? Ask the user for the password. The password is secret. The user inputted secret. The password, you check if x is equals to secret. In this case, is true, right? Then what if, so just now we wrote it that way, right? But what is another way to do it? So just now we wrote if x equals to secret, then the door opens. Otherwise, the door was, say, wrong password. What if we want to swap the two print statements around? We actually put a not in here. Can you guess what the not does? So if not this statement, x equals to secret,
means that anything other than x.
Close. It's actually this x equals to secret is actually evaluated first, right? This x equals to secret is evaluated first. In this case, it's a conditional whether it's true or false. The not keyword in front of it will flip the truth value of this. So what that means is that so not true, what would it do? It will flip it. And not false, it will flip it. Does it make sense? Or confusing?
Not true is false.
Yeah.
Not false is true.
Yeah.
Okay.
Yeah. So
Isn't it the same as doing it that way?
in this case, we don't see a huge convenience brought about by doing it, right? That is right, but in bigger programs, in other programs, it might be more useful to consider the case where some condition is not true. Like we might want to flip it. So example, right, would be, let's say x equals to 10 over there. So if let's say, let me think of a good example. So let's say we wanted, okay, so let's say we ask the user for password. Okay, then in this case, if x is the correct password, right? If x equals to some correct password, print welcome to the secret club, else print shoe. Okay, so this is a password system that we just programmed. It works as well, right? But if let's say we wanted to have a lot more lines over here, a lot more lines of code, right, over hundreds of lines, then it's going to be a bit harder to read, because if I have many lines over here, then somebody else comes along and read my code. I share my code with someone else. They see this conditional, then they, okay, so this entire chunk will be executed if the condition was true. But then let's say this entire chunk was super long. Okay, let's say this entire chunk was super long, like that. So he comes along, he reads this. Then he goes, then he scrolls down, and he suddenly sees this thing. And then he's like, where did this else even come from? Then he must scroll all the way up to find the corresponding if statement. The else statement can only come after if statement, right? Then he must go all the way to find here. Then he must go all the way to find at the bottom. It's a bit hard to scroll all the way down, especially if this is very long and complicated. So it's much simpler if we took all this long code, right? This long code over here, put it here. This one put here. We flip the two of them around, but then now we want to only let in the person. Now it doesn't make sense, right? If he got a secret password, why is he being shooed away? So we want to flip this conditional around. You can think of it as a bracket around this entire thing. The entire conditional is evaluated first, then we flip it. So that's the use. Now he can see very nicely, if he get wrong password, right? Wrong password, he gets shooed away. Otherwise, he can scroll and he doesn't need to worry about where to find. This is not there's other cases where it might make more sense, especially when you use with like conjunctions like and other stuff, or statements where it's more apparent, but this is just a feature that we can use. Okay, so if not, then I think you're ready to do, let's do Q5.